Hello again. We're in week 9. This is the second lesson of the week, and let's just get started. We got more standard form for you today. We're going to learn how to graph in standard form today, so it's kind of exciting. Okay, so one thing that I noticed when I loaded my lesson, my PDF into Notability this week is that it popped up with a weird name. Maybe that happened to you, maybe it didn't, but here's just a little reminder. If you tap on the name of your document in Notability and then you click the little X on the right-hand side, you can get rid of everything. This is lesson 9.3, and you could just put 9.3. That would make it organized for you, but you could put graphing in standard form as your title if you would like. I just want to make sure that you know what lesson we're on. All right, so kind of backtracking a little bit, we're going to talk a little bit about what is standard form. And standard form, as this little paragraph explains, is when you have ax plus by equals c. Now, it's not always plus, it could be a subtract, but the big idea is that both the x and the y are on the same side of the equal sign here. Whereas the form of the function we're used to seeing is y being alone on one side, and then we have mx and plus b on the other side. So last lesson we talked about how do you convert from slope-intercept, or y equals blank x plus blank, to the other way around. How do you go from standard into y equals mx plus b, and then that can allow you to graph. That's one way to think about it. The other way to think about it is to graph using intercepts. So we'll kind of talk about all of this today, and we'll expand our understanding of visuals as far as these two forms are concerned. All right, so the first thing we're going to do is we're going to go through this example and we're going to circle which equations are in slope-intercept form, and then put a box around equations that are in standard form. So looking here, I can see this first one is in slope-intercept form, or y equals mx plus b, because our y is alone on one side. Pretty simple. This next one I could see is in standard form because the x and the y are on the same side of the equal sign. Again, you might be a little confused by this one because the y technically is naked, right? It doesn't have any numbers with it, but the x is on the same side of the equal sign. So again, this one is standard form. And last but not least, we have the y alone on one side of the equal sign, the mx plus b on the other. So this one is going to be slope-intercept form, or y equals mx plus b. So let's get after a couple examples. We're going to try to find the x-intercept and the y-intercept of equations and then use that to graph. So how do I calculate an x-intercept? And this is going to be the same thing for both, just switching the idea. You're going to plug in y equals 0. And same thing for the y-intercept. You're going to plug in x equals 0. Let's explain a little more. So you're going to draw the graph of this function here in standard form. And you have to find the x-intercept and the y-intercept first. So in the previous video, I kind of did it pretty quickly and I showed a little trick, which I'll explain to you now. But let's go through it a little slowly. So here's our equation. We're going to start off with that. Negative 3x plus 5y equals 90. First, we're going to find the x-intercept. And remember, the x-intercept is when y equals 0. So we're going to plug in to y a 0. Negative 3x plus 5 times 0 equals 90. Remember, when the 5 is next to the y, it means multiply, just like when we solved for b, right? You always had to multiply the slope times the x, the m times the x, and before you solve for b. Same idea here. The difference is that whenever you multiply by 0, you get 0. And so this becomes negative 3x plus 0 equals 90. And if you wanted to do it a little bit slower, but the way that might make the best sense to you, you could say, okay, I'm going to subtract 0 from both sides. That means I have negative 3x, 90 plus 0 or 90 minus 0 is just 90. And then when we divide both sides by negative 3, we're going to get x is equal to negative 30. So really what's going on here is we found the point where y equals 0. That's the y part of the point. And then the x is negative 30. We solved for that. Okay, so now I'm going to show you how to do the y-intercept. It's exactly the same way, but I'm going to show you a little trick. So we have negative 3. We have to plug in, this is the y-intercept, and this is when x equals 0. So 3 times 0, right? The x is 0 when we're finding the x-intercept, plus 5y is equal to 90. And since this becomes 0, and since subtracting 0 from both sides doesn't change anything, you can just cross out the x. So when you're finding the x-intercept, the y-intercept or the x-intercept, you can just say cross out the opposite variable. And we'll do a couple examples with that trick. So we have 5y equals 90, dividing by 5. We get y is equal to, let's think here, 30 divided by 5 is 6, and then 30 times 3, so it should be 36, but let's make sure we got this right. So 90 divided by 5 is equal to 18. Oh, I'm glad I checked. Mental math is not my thing. So y equals 18, and so since x is 0 and y is 18, we would write it like 0, 18. Okay, so now we put these points onto the graph. You might be thinking to yourself, this is not as pretty of a graph and not as clear of a graph as it would be if we did y equals mx plus b. That's fine. You are more than welcome to try and graph it by converting to y equals mx plus b and then graphing from there. But really, as you'll see as we do a few more examples, it's a lot quicker to do it by finding the intercepts, graphing those 2 points, and then connecting them. Don't forget to extend the graph on both sides and put the arrows on there. All right, let's keep going with a few more examples. I'm going to pause for a second and I'm going to put the password. Okay, here is the password for this. Remember, you need to make sure everything is capitalized correctly. So the S is capitalized, the O is capitalized, there's a space there, the I is lowercase, and the D is lowercase. So January 28th, which is next week Thursday, is the last day of the semester. You need to make sure that you're caught up in all your classes, or that you've talked to your teachers about getting caught up in your classes. Also, know that the next week after that, you're going to have new teachers in some of your classes. You're going to have a completely new schedule, most likely. And so it's just a big transition. So prepare yourself to be ready for the week after next and the end of the semester. Let's keep doing. Keep going. We got 2 more examples left. All right. So we are going to find the x-intercept and the y-intercept. And I'm going to show you the quick way to get it done. So if I'm trying to find the x-intercept, that means I'm going to cross out the y. So the little clue that I'll give myself is to cross out the y. Because we're plugging in 0 for y, it means that it becomes 0. It doesn't affect the rest of the equation. So I have, for this one, I have 4x is equal to negative 12. Whatever is with the y, it goes away. Then all we have to do is divide by 4. And we get x is equal to negative 3. So our x-intercept is negative 3, and we just put that point right there. Pretty simple, right? You're probably wondering, why did you spend all that time going through the previous way you showed me? It's because I really want to make sure that you understand where these tricks come from and why they work. Yeah, I mean, that's the end of it. I would be a bad teacher if I just showed you the trick and didn't explain why it worked. Okay, let's do 12 divided by 1.5. 12 divided by 1.5 is equal to 8. So I got y equals 8. And that's our b value. Remember, the y-intercept is the same as the b value. And then in order to graph this, I'm just going to connect my 2 points here, and then I'm going to extend it off a little bit in order to make sure that I'm bougie. I'm doing it the fancy way. Got my arrows. I'm ready to go to the Queen's Ball or whatever you want to say. Putting those arrows on, extending the line a little bit really shows you're here for it. All right, let's do the next one. This one's going to be kind of interesting. So if we're looking for the x-intercept, remember that's when we cross out the y, because we're solving for the x. We don't care about the y. And technically this is a -1, but we're just getting rid of the y and the number in front of the y. So this becomes 5x equals 10. Remember that negative belongs to the y, so we don't need it. Divide by 5, and we get x equals 2. You find on the x-axis +2, and you put your number right there. Let's do the y-intercept. This one's got a tiny little trick to it, but it's nothing you can't handle. Remember, cross out the x if you're trying to find the y-intercept. Another way to think about that is that you are solving for the y. What does the x equal? It equals 0. Also, we're not solving for the x, we're solving for the y-intercept. All right, so we got -y equals 10. And that's actually a -1y. So remember, when you are crossing out the 5x, that negative belongs to the y. Technically, it belongs to the -1. It belongs to the 1 that's with the y. So we have y equals, and you're always dividing top to bottom. Sorry if I didn't explain that before, but you're always dividing top to bottom. 10 divided by 5, 10 divided by -1 on your calculator. It would look like this. And you get -10. So we're going to go ahead and put that point at -10 on the y-axis. Remember, that's the same thing as the b value. So if this process has you like, what? You are allowed to do these problems the same way we did the problems in the last lesson. Just these ones, it's a little quicker, it's a little easier if you are to approach it by finding the intercepts, connecting them. You know, it actually is a little quicker and easier to do it this way. All right, you guys, go ahead and try the next 2 examples. Good luck. All right, you guys, this next one is the challenge. So it's got some decimals, it's got some fractions. It's nothing that you can't handle. Let's get after it. So here's our equation. We're going to find the x-intercept first. Remember, that's when we get rid of the y. So we have -0.2 is equal to, x, almost forgot the x. And then we're going to divide by -0.2 on both sides. Really, this is not that much different than what we did before. It's just got a decimal, and sometimes I know that it can be hard to know what to do when you have a decimal. You're still just dividing by the number because it's in front of the x. So we got -20, so we're going to put -20 on here for the x-intercept. Let's do the y-intercept. So the y-intercept is when we cross out the x. We have 1/4 y is equal to 4. You can do this a couple different ways. Remember, the trick is that you flip and multiply by the number that is opposite, or you could just divide by the, divide by 1/4, but that's the trick with fractions if you remember from the beginning of the year. We're putting 16 on the graph, and I'm just about out of time, but you're connecting them. Good luck on this challenge question.